driven more than 28 miles. But a big storm is coming. Looking down, it sees dust accumulating on its solar panels. Looking up, it sees less and less.
And suddenly, the sky literally darkens over the course of a period of just a few short days. And the last image we have, looking towards the sun from Opportunity, effectively shows us in being in darkness.
The dust storm blocked out all sunlight from reaching the solar panels.
14, MER project manager.
14.
For 8 months, Opportunity's mission team sends ping after ping to try to wake up the teenage rover.
MER 1, spacecraft ID 253.
It never did power on again to call home.
Finally, NASA concedes.
And this is Station 14 on behalf of the network. It's a sad day for all of us.
MER project off the net. Thank you.
Because Opportunity was operating for 14 and a half years, people got very attached to the rover. And I can tell you that the people who were on those conference calls when we decided to end the mission were very sad.
Opportunity broke the mold for rover longevity. Perseverance is designed to be even stronger.
The first thing the rover has to survive, of course, is all the testing we do to it.
They run Perseverance through everything Mars could throw at it. Severe temperature swings, down to 200 below zero Fahrenheit. Blowing dust that could grind gears and blind cameras, but at least not cut power.
Perseverance is nuclear powered. We don't have to worry about dust storms.
It's called radioisotope power, essentially a nuclear battery. It converts the heat from the decay of plutonium into electricity. It could power Perseverance for years, if it survives the journey.
You design a rover for the sort of worst case scenario. The worst case shaking on launch, the worst case hard landing, all have to be survived.
If Perseverance lands safely, it will see more than what's on the surface of Mars. It will take a peek underground at layers of history. On Earth, we see these layers at the most unlikely places.
When we do geology on the Earth, we often get fortunate enough to have a road cut like this from building a highway. And that road cut allows us to see the layers that have built up over time. Now, in a lot of cases on Mars, we're not going to be able to get some kind of cross-cut through the terrain like this. And what we have to do is use a remote sensing instrument called ground-penetrating radar. I work on an instrument called SHARAD, the shallow radar, on the Mars Reconnaissance Orbiter. SHARAD transmits signals, and that pulse will travel down through a layer like this. And each time that signal bounces back to us, we build up a cross-section, just like you see in the road cut here, in order to tell the geologic history of that area. They might be differences between sand layers and ice in the polar caps. But there's no substitute for being able to look in greater detail at what's right below your feet. The Perseverance rover will carry an instrument called RIMFAX, which will measure the subsurface layers beneath the rover down to a shallower depth than SHARAD, perhaps 10 meters, but with much finer detail. Now, someday, astronauts may be able to simply walk up to an area like this on Mars and make observations of the geologic history through the layering. But for the time being, instruments like SHARAD and RIMFAX are invaluable.
Perseverance is the first rover that can see underground. But it also carries something that could see over the horizon. At NASA's Jet Propulsion Laboratory in California, Perseverance has passed all of its flight tests. It's a month away from leaving home. It's built on the legacy of the rover that came just before it.
After the Spirit and Opportunity Mars exploration rovers Curiosity became sort of the big sister on the block.
In 2012, Curiosity became the next rover in line for Mars. It's a major upgrade.
So it's about the size of a small SUV. In terms of its complexity and its size, it's just far beyond what we've done before.
All around the country, Curiosity sparks Mars mania. On landing day, Curiosity creates a buzz in New York City. At NASA, it creates a roar.
Touchdown confirmed. We're seeing on Mars.
The biggest rover yet is safely on Mars.
Curiosity will take us.
It lands inside a fascinating landscape.
Gale Crater, I think, really is the place on Mars where you feel like you are on Earth.
There's evidence that Curiosity has collected that there was a liquid water lake inside this crater.
If you had been standing there, you would have been knee-deep in running water, and it would have been drinkable. I mean, you could take a cup and scoop it and drink it.
Curiosity drills into this ancient lake bed, finding thick layers of sediment that took thousands of years to build up.
For me, that was a real aha moment, because suddenly here I was staring in the face sediments that were very much like the sediments that were being deposited in the lake where I grew up in northern New York. And I was kind of dragged kicking and screaming into this idea that, by God, there was an ancient lake on Mars, and it was there for a good long time.
We now think water flowed on the surface for up to 1 billion years, but dissipated about 3 billion years ago.
The reason that the water became less stable on the surface is that the atmosphere changed and became very thin. Eventually, it became very dry and cold.
Perseverance will look at what water left behind, especially in craters.
Perseverance is landing in a place called Jezero Crater, where we see, because of an inlet channel and an outlet channel, that water once filled that up and overflowed. Perseverance is going to go and evaluate those sediments and those rocks, seeking signs of life.
The search begins with the rover's amazing arm.
So I would say the robotic arm is incredibly important for the mission because it has everything on its hand. And in fact, as I'm talking to you, you can see me moving my arm because it is so intuitive also. You're thinking about an arm just like yours, an arm where the fingers are the instruments, and you immediately can picture exactly what you will do if you were a geologist standing on the surface of Mars. Bring it down, put it here, let me see it.
At the end of the arm is a whole new suite of instruments that will look for traces of past life.
The robotic arm also has a drill in it, which is the actual unit that will collect the sample.
A drill on a rover is old news, but the fate of the sample could be big news.
Perseverance is going to collect and cache samples for possible return to Earth at some time in the future.
This rover will begin the most ambitious robotic space handoff ever attempted.
Perseverance will drill down and collect samples and put them in an area where a second rover can come in the future and pick them up. They'll be put inside a small rocket that will be launched up into orbit where they'll be captured and eventually return to Earth at some time in the future.
If Perseverance finds evidence of life, we'll need the sample on Earth to confirm it. Within a decade, we could be holding the first evidence of alien life in our hands.
The kind of holy grail is sample return, and Perseverance is the first step along that path.
Packed inside Perseverance is another space first. It looks like a spider learning to fly. But it's the first interplanetary helicopter.
Ingenuity, which is the helicopter that we're sending to ride along with Perseverance rover, is designed as a technology demonstration to, for the very first time, show that we can operate a powered flight aerial vehicle on the surface of Mars.
NASA creates a chamber simulating the atmosphere of Mars, where liftoff will be 100 times harder than on Earth.
With the atmosphere so thin, there's very little material for the blades to push against. So it's very light, and the blades are very large in order to get enough lift to be able to lift off the ground.
The copter passes the test on Earth. On Mars, it will have to fly solo because radio signals take an average of 15 minutes to travel between Earth and Mars.
It has to be done completely remotely. You have to be doing it without any real sort of real-time joystick control of where this thing is going to go.
If it works, Ingenuity could scout ahead for Perseverance, take detailed photos, and transmit them back to the rover for a sneak peek of where it might go. All while flying into the history books as the first powered flight of an aircraft on another planet. But it has to get off this planet first. The first step to Mars is a cross-country trip from California to Florida. 16 semis truck in pieces of the capsule that will carry Perseverance to Mars.
Those can all be sent separately, but the rover itself, fully assembled, was sent on a large airplane to Cape Kennedy.
At the launch site in Florida, they tuck Perseverance into the capsule, cradle it into the top stage of the rocket, and worry.
You're in a situation where you've got years and years of work wrapped up, folded, origami style almost, on the top of a giant bomb. And this thing goes bang and flies off into the distance. And it does so in a real hurry. And so there's a lot of personal fear that what happens if something goes wrong?
Launch day awaits. Just as the new Mars rover prepares to launch off the Earth, Earth suffers a devastating blow.
The rover is perfectly named as Perseverance because getting this rover to the launch pad occurred during a global pandemic. It's hard enough to get a rover built on time and with no mistakes in it, and you layer on a global pandemic, that's an extreme amount of stress and, pressure.
If something delays the launch, Mars won't line up this closely to the Earth for another 2 years.
We're going to get one shot at this.
Perseverance will ride on an Atlas V rocket. The boosters come from Alabama. The payload adapter comes from Texas. And the physics come from experience. It's not easy to hit a moving target at a cosmic distance.
The navigation people are trying to do this 100 million mile hole-in-one. The spacecraft is actually put to a place where Mars is going to be. So think about a quarterback throwing a long bomb downfield, even though the receiver is still 20, 30 yards away from where he's going to catch the ball, and knowing that the two are going to come together at that last second at just the right time.
What a beautiful morning here on the Space Coast. Welcome, everyone. Behind us, the star of the show.
After years of work, the moments before launch are like a vacuum.
Currently working, no issues on the Ranger, the launch vehicle. Appears to be ready to proceed.
They have a lot of their lives invested in these things. It's as if your child is leaving home. That is literally what is happening. It's just, in this case, the child is a robot that is going to another planet.
Go Atlas.
Go Centaur.
Go Mars 2020.
2, 1, 0. Release and liftoff.
Powered by 4 boosters, it leaps off the pad.
The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Barely 30 seconds in, it breaks the sound barrier.
And Mach 1 Atlas V is now supersonic.
90 miles up, the solid rocket boosters peel off.
And we have a good indication of SRB jettison of all 4 SRBs.
Just 4.5 minutes in, the rocket drops back.
And we have good indication of Atlas Centaur separation.
Perseverance puts Earth in the rear view mirror.
To have watched this rover launch to Mars was an incredible feat.
Successful separation of Mars 2020 with the Perseverance rover.
There we go. Awesome.
Now it enters the cruise phase, 6 months of silent sailing. That will end with a terrifying 7-minute leap of faith.
When the spacecraft gets to Mars, it's literally going thousands of miles an hour. And so we've got to go from thousands of miles an hour to 0 and not do a bug on a windshield.
The heavier the spacecraft, the harder it is to slow it down. Viking was light enough to land with a parachute and some retro rockets. The heavier Spirit and Opportunity rovers needed giant balloons to cushion their impact. Now, 1-ton Perseverance will take a far trickier path.
As the spacecraft encounters the upper part of the atmosphere, it will heat up. Once it slows down enough, then the heat shield will come off. Once we've slowed down enough on the parachute, then the rover will separate from the back shell. That's when the engines on the descent stage will actually ignite and slow us down to eventually hovering over the surface. The rover itself will actually be gently lowered, spooled on cables. Once the wheels touch the ground, the cables are